So we're in 5.5. 5.5 is about a thing called the ambiguous case, or SSA triangles, which from geometry experiences, we never spelled that backwards for swear word reasons. Anybody just in the English language, do you know what ambiguous means? If a sentence is ambiguous. It means you could take it a couple ways. Like you hear the sentence and you're just not quite sure how to take it because it could mean multiple things and you're trying to assess tone or whatever. An SSA, explanation of SSA triangles are, it's triangles that can turn out in a lot of different scenarios. Some of these pictures on the board are going to have no answer. Some of them are going to have one answer. And some of them are going to have double answers where one triangle actually becomes two, essentially. So here's our scenario is you would have an angle that you knew what it measured. And you would know one of its sides. So like this side is set in stone. This angle measurement is set in stone. But this angle, you don't really know how far into space it's going to go. And then you have this mystery third side that's going to slot in over here somewhere. So if I wanted this third side to be this long, from pinky to thumb, if I wanted it to be that long, it could be located right where I'm locating it now, or it could be located over there. Those are both that long. But whether it's going to go in or out, we don't know. Like this triangle could be shaped two different ways. If I told you I wanted the third side to be this big, well, you can't do it. If I wanted the third side to be this big, that could only be like down here somewhere with that continuing a ways. So depending on how this is set up for you and what the sides and angles are, like we have this is set in stone and this is set in stone and the length of the third side is set in stone, but its position isn't. And you could get impossible situations, single answers or double answers. So we save this for its own day. Anybody not understanding like the crisis at hand is, it's difficult to predict what's going to happen with these. So if we look through those pictures over there, we have two tools now in our toolbox. Pythagorean theorem is out. Why is that out?
Only right triangles.
Only right triangles. Sine and cosine are out. Why are, like Oscar and his heap of apples, sine, cosine, tangent, why are those out?
They also need to be right triangles.
Also right triangles. What two tools are in over the last week or so? Law of sines, potentially. Law of cosines, potentially. When were we using the law of sines?
To get angles.
Maybe, maybe not. How did the picture have to be constructed for law of sines to be possible?
Two angles on one side.
Maybe, maybe not.
An opposite pair where both are known.
We have to have an opposite pair where we know them both. So if we look through the pictures on the board, does law of sines seem like it might be in play?
Yes.
Seemingly. Because like, who's the pair here that helps us? 27 and 4. 105. In each of these pictures, there's going to be an angle and a side where we know them both. Like we knew this angle, we knew what the length of this side was, we seem to have a pair where we know them both for this type of triangle. But here's a detail that springs out today. I told you this, but it didn't matter to our life until this moment. We can't use the law of sines to get angles unless, does anybody remember that note? Didn't matter till now, we never used this note, I just dropped it out there in advance and told you it would matter someday, and today's the day.
You know in advance the angle is acute?
You have to know by some sort of logical process that unknown angle you're trying to get, sorry about the squeakies, is acute. So if I go to look at this, 27 and 4 are linked. 5 would seem to be ready to lead you to this angle, possibly with law of sines. But do you know that that angle is acute? Shaking our heads no. What do we know about this angle? If 4 is leading us
It's
to
bigger than 27.
It's bigger than 27. If 4 is going to lead us to 27, 5, which is bigger than 4, would have to lead us to an angle bigger than 27. So could you be bigger than 27 and be acute?
Yes.
Yes. But do you have to be?
No.
No, because acute means that you're
Less than 90.
less than 90, but you can be bigger than 27 and obey or disobey that thought. Can anybody spot, let's label for conversation purposes, A, B, C, D? Can you spot a triangle out of A, B, C, or D where the angle would be acute?
A, B, C.
I'll agree with B, because if 3 is opposite 70, 2, which is less than 3, would have to lead us to an angle less than 70. Law of sines, A-OK. A triangle like this would have one answer. I'll agree with C. If 4 is across from 100, 3 would lead us to something that has to be less than 100, but even stronger than that. Why would we know that this has to be a cube?
Because triangles add 180.
Triangle only adds a 180. So if this hogged 100 degrees, it only leaves these 80 to share. So that could be a law of sines problem. That would also have one answer. I did not agree with A. Why?
Because 6 is bigger than 5.
True. So what do you know about this?
It's going to be greater than 100.
That would have to be greater than 100. If 5's across from 100, 6 would be opposite something over 100. We'll reserve comment on that for a second. But this, we cannot use law of sines. Okay? If 27 is across from 4, 5 is tempting you to try to go get this angle, but that's more than 27. That's not going to work out. Brief conversation as to why this is a problem. Grab your calculator, punch in sine 150. And I'm hoping it says 0.5, which you know is a half. What other angle in your life history was the sine going to be a half? Where have you seen sines be half in your history?
Sine of 30.
Yeah, where did you see that before?
On the chart.
On your chart. So if your triangle really had, let's do this on your calculator now. Go second sine of your answer.
So my sine was not 0.5.
Okay, check your
My sine
mode.
was 50.
Yeah, sine 150 should be 0.5
Okay. And then what mode should it be in?
degrees.
Degrees.
It's the hit the mode button, and then it's like the first or second choice.
Mine says, oh, okay, I see it. Okay, thank you.
Okay, so if you do sine, and then you do inverse sine, where do you think you should have just ended up? Like I give you a number, you do the sine, then you do the inverse sine. Where does it feel like that should take you?
Back to 150.
Back to 150. But where did it take you?
To 30.
To 30. Your calculator could never take you to an obtuse angle. If you went looking for 160, what angle do you think your calculator would force on you like it just forced 30 on you instead of 150?
40.
Disagree. I'll tell you 20 and tell you there's a relationship here. If you went searching for 170 and 170 were the truth, your calculator would tell you a lie and it would land you on who do you think?
10.
agree with 10. What's the relationship?
180 minus 170.
Yeah, correct. They add to 180. So if 140 were the true answer, and that's the answer you needed to find, your calculator could not find it. It would instead give you 40. And that's an unfortunate thing. So that's why I tell you, you can't use the law of sines to get angles unless you have a way to know the angle is acute before you even start to pushing the buttons and doing the process. Because it's always going to give you an acute angle. If the angle is indeed acute, go ahead and get it. But if the angle even might be obtuse, law of sines can't get it for you. On this problem, it doesn't even matter because we're not after the angle, we're after the side. So the homework's going to start off with 8 of these where you're after the side. It's asking you to just go ahead and get the side. We don't need the angles. Where tomorrow's lesson will go, though, is to a world where I give you 3 pieces and I want all of them. But today, they'll give you 3 pieces, and on the first 8, they only want the side. So that whole conversation is not dramatically affecting your life yet, but it does matter. Okay, you're not going to be able to try to get angles with law of sines unless you know the angle is acute. So if law of sines is out, who's in?
Law of cosines.
Law of cosines. So should this set up x squared equals, 4 squared equals, or 25 equals?
4 squared equals.
4 squared equals. Why is it that the 4 squared equals set up?
It's opposite the given angle.
Opposite the angle. Law of cosines also focused on finding some opposites where they were both named. And 4 and 27 are opposite in the picture, so they're going to be opposite in the formula. How would the rest fill in?
25.
25 could go first or second.
X squared.
X squared could go first or second. Those are interchangeable. It didn't matter who was where.
Minus 2 times 25 times x. 2 times 5 times.
2 times 5 times x. And I didn't leave quite enough space because I need to fill right here.
Cosine.
Cosine 27.
I can't.
Anybody mad at setting the law of cosines up? This is new to your life. Okay, last time we did the law of cosines lesson, we had a bunch of them that were x squared equals, and we just had to algebra do the root of stuff. Sometimes the x was here, and we had to do like a lot of algebra opposites to get everything cleaned out of that to get the angle. Since we were getting an angle, eventually we had to do inverses. This is a whole new setup. We've never had one set up where there were x squareds in there and x's in there and other stuff in there. So how do we do algebra and solve this when there's x squareds and x's and numbers all over the world? You get it to equal 0. So to get that to equal 0, you'd have to do what with the 16? Makes the 25 a 9. I'll clean up 2 times 5, make 10. Then what do we do? Use your program. That's why we wrote the program on Friday.
Nice.
Your program is going to ask you for A. Who is A in this world?
1.
1. How do you find the A?
That's what the x.
It's the number with the x squared, which is an invisible 1. It'll ask you for a B. Who is B?
Cosine 27.
Negative and 10 and cosine 27. Everything with B, or everything with x, is B. And it'll ask you who is C?
9.
C is 9. Punch some buttons. And I'm thinking the program is going to say 7.75.
Yes.
And it's also going to say 1.16. So for today, you would just say 7.75 and 1.16 are both the answers. Because as we discussed before we started, ambiguous means this could go different ways. There might be 2 answers. There might be 1 answer. There might be no answers. Okay. If this were a future day, what just happened is this triangle cloned itself. So you would have, if our goal is in a future day, and it will be, to get everything figured out, you would put 7.75 on the original triangle, because that's a valid answer. You would create a clone that has 27, that has 5, and that has 4, but unlike its clone, there is a 1.16 that lives there. Then you'd set about finishing this one based off of its answer. You'd set about finishing this one based on its answer, but you don't have to do that today. But that's where tomorrow is going to go is, if this gives you a double answer, you have to clone it. And now you're not looking for 3 facts anymore, you're looking for 6. Here's one way you could get one answer out of this. If this gave you a positive answer and a negative answer, can triangles have negative sides? No. So if it gave you a negative back from your program, pitch it. What if it gave you 2 negatives back from your program? It's impossible. You'd pitch them both. It also might be impossible because your program has a point where it'll tell you that there is no answer. That's possible too. Okay? So if it gives you 2 positive answers, there are 2 positive answers, and there's clone going on here, kind of like that first picture I described, where the side could come in and have like a mini triangle, or the side could go out and be a bigger triangle. That could happen. 1 positive, you just keep the 1 answer. 2 negatives, or if the program fails you, there's just no answer to that. Question there? Let's take this one on and then have a conversation. So let me call that X. And let's try to get after it. We could go 25 equals
36 plus x squared minus 2 times 6 times x cosine of 100.
Agree.
Correct. 25.
Subtract the 25, so it equals 0, and we have 11. And I'm not going to write this all down again because I don't feel like it. And then punch it in, run your program. Here's an interesting fact on your calculator. If you just hit enter, it'll rerun the program you just ran. You don't have to go back through the program menu again. If you want to run it again, just hit enter. It's ready to rock and roll again. A is again 1. A will always be 1. B is again negative. It'll always be negative. In this case, 12 cosine 100. C is the 11. And this says no answer. How could we have spotted a no answer in an earlier conversation that I cut short on purpose because I didn't want to have the conversation yet? Triangles can only add up to 180. So if 5 is across from 100, 6 logically has to be across from something bigger than 100 because 6 is bigger than 5. 6 has to have a bigger friend than 5. So this would have to be over 100, at which point you're already over 180. You're over 200. There is no answer to that. If you saw the no answer coming, great. Just find that before we start. This we decided there was 1 answer because if 3 was leading us to 70, 2 is leading us to something under than 70. Let me work this triangle 2 ways for you. I'm not going to work this one because it would go the same way. So it was worth talking about having 1 answer, but it'll have 2 solution paths. How about this? How would this one go? Could we do lost signs? It's not impossible. But could we do lost signs? No, why not?
Because you have to know that the angle would be acute.
And what do you know about this? What about its size?
It's bigger than 70.
It's bigger than 70. So it might be in the 70s or 80s, which is okay, but it could be in the 100s, 110s, 120s, which is not okay. So this would have to be a law of cosines problem, and you don't know whether it has 1 or 2 or maybe even none until you try to run your program. So this would get solved just like the one I solved to get the 7.75, 1.16. That's the path this would take, and I wouldn't know how many answers it would have until I had them. This, I'm positive, this is going to have one answer. Law of sines is only going to ever lead you to one answer. Law of cosines, a little bit mysterious. Question about how to tell if it had none versus one versus law of cosines, we don't know. If this is a future homework where my goal is to get everything, I would go ahead and do law of sines to get this angle. I don't think that's the most efficient way to do tonight's homework necessarily, but if this is a future day where my goal is to get them all, I think I'd go get that first. Law of sines look like this. Can somebody get that going? Who over who?
3 over sine 70 equals 2 over sine x.
That could work. Not wrong, but I personally, for solving purposes, I'd rather get the variable on the,
Left.
and on the
Top.
top. I think it's easier to solve for a variable if it's on the top. It doesn't have to be. What you said is fine. You were going to have to like completely cross multiply. I would probably prefer a variable on top. So let's do a law of sine setup with variable on top left.
Would it be sine x
It would be sine x because sine always goes with the angle, which is x.
over 2?
Agree.
Sine 70 over 3.
Agree. To get the x alone. Yeah, you don't have to move everything, you just have to move the 2. So we could go 2 sine 70 divided by 3. Make sure when the calculator starts the 70s parentheses that you wrap 70s parentheses. And I'm going to have to trust you guys to punch this. It's going to be a decimal number for now. That decimal number is not the final answer for x. What are we going to still have to do after we get our decimal answer?
Inverse?
Inverse sign. So if you're showing a decimal, what might this be? What was the decimal showing?
0.62.
Okay, I was going to guess 0.6. I should have guessed 0.6. That would look good. So second sign that 0.6, and you're going to come up with something. 50? No, less than 50s. 40s, 30s, something like that.
38.8.
Then what would be the next easiest item to locate?
Add the other angle.
The other angle. The other angle would be easy to locate.
Add 38.8 and 70, and then 180 minus your answer.
So that'll be
Is it gonna be the
51.2. Then let me call that y. What's the easiest way to get to y?
Right.
Isn't it 71.2?
Yes. Good eye. Thank you. Getting the y? Law of sines, law of cosines.
Law of sine.
I would do law of sines. Could you do law of cosines?
Yeah.
Could. But I think your observation from doing both laws is it's easier to do law of sines. Like law of sines is just easier to manage. So y over,
sine 71.2.
it is. And when you punch that in, I'd use the answer button, not 71.2, because that's actually longer than 71.2. Equals
3 over sine 70.
3 over sine 70. This has to go be with 3. So I'd punch in 3 sine answer, divide by sine 70. and that's gonna be a little more than 3. Not much. Anybody have it? 3 sine answer, divide sine 70, a little more than 3?
I have 2.84.
Shouldn't be, because the 71's bigger than 70, so this has to be bigger than the 3. Something went wrong somewhere.
3.02.
That seems possible. That would be the most effective way to get all of the answers if you had to get all of the answers. Law of sines twice is going to be the easiest path to do that if you can get away with it. Rediscussion, if your only goal was to get the y, that's it. That's all you needed. If you didn't need all 3, because tonight on the 1 to 8, you don't need all 3, you just need the side. If you just needed the side, you don't have to go through all the work of getting the angles to get the side. You can go ahead and just get the side. Not using law of sines, using law of cosines, how would it set up?
For which side?
If we're trying to get the y, if our only goal is to get the y,
Okay.
and we don't care about the angles, because that's how the homework will be set up tonight. Y squared equals, 3 squared equals, 2 squared equals.
3 squared equals.
It'd be 3 squared equals
4
4 plus
y squared.
y squared minus
2 times 3, or times 2 times y. 70.
cosine 70. We'd have to get this to equal,
0,
which makes this,
negative 5.
and then we'd
Plug it in.
plug it in to your program. Let's run it up. So A again is always 1, every problem we're doing this. The B would be negative 4 cosine 70. C would be the negative 5. It should give us the 3.02 we already agreed on, and then probably a negative throwaway answer.
Yes.
So that would get us the if all we wanted was the 3.02, that would be the quickest way to get just the 3.02. Could we, from the 3.02, go get angles? Is that possible? Once we got the 3.02, could we get angles? Yes, because we could do law of sines to get this, and then like 180 to get the other one. That could still work if we wanted them all. Moral of the story is, if you want the quickest way to do 1 to 8 tonight, just do law of cosines every time to get the sides. But if you want the most efficient way to get all of the answers figured out, it's quicker to use law of sines when it's legal to get all the answers figured out than it is to bother with law of cosines and the quadratic formula. Question there?
You're good now.
So 1 to 8, you're getting the sides. When you go to do 9 to 12, the homework goes to 12. 9 to 12, they have you getting angles. So it is going to be a little bit like this-ish, that you're going to have to get yourself an angle instead of getting the side. So that's going to happen a little bit on the 9 to 12. But 1 to 8, you're just going to get the sides. 9 to 12, you're going to get an angle, so it'll be a little more like that one. That's it, 1 to 6, 1 to 12.